Welcome back. This is Module 13 Guided Lab. This is breaking a monolithic application written in Node.js application into several services written in Node.js, and they will be running in a Docker container. So we will have like an existing application where we have users, the threads, posts, services. It's just like enable user to create posts in the threads. And this is written in Node.js web framework, and we want to divide it into 3 microservices. As we know, these are tightly coupled, and we want to make them decoupled from each other. So the first point in this lab, in the first task, is basically to go to Cloud9, and we open the Cloud9 IDE, which is the one it created for us. And we will download the sample code for this application. And then we will test that the code is running successfully, and we will use it as well to containerize it and divide it into small pieces of microservices. So let me now wait for Cloud9 to be ready. And this could take a few minutes. The first thing I will point is the link for the sample code. And this is basically another command to unzip the code into the folders. Now, once you unzip the code, you will have 3 different folders. There is one no container, which basically contains the monolithic implementation. And there is 2 containerized, which contain a file which is created as a monolithic application, and we can run it as a Docker container in Amazon Elastic Container Service. And the third one is going to be the 3 different microservice implementation that we will have to run our application. So the first thing I'm going to do is to paste the link to get the sample code. And this is basically will pop the folders in our environment here. And now we want to run them. As we know that these are written in Koa, and we are going to install the Koa framework, which is a web framework to build a synchronous server-side application. So we are going to go to the folder where is 1-no container, and we will install Koa and Koa router, which basically to serve the routes from the application. If you open the no container server.js, you will find that this application is basically serving different API routes. So API/users to get all user, API user/user ID. You pass a specific user ID, and you will get the user ID from the DB user, which is this file here in JSON. After we finish the implementation, we just want to make sure we can test this application and we run it successfully. So we can, you feel free to spend some time reviewing task 2.2 to understand the code and to learn more about this framework. So the last thing I'm going to do is in step number 14 is to start the code. I will open a new terminal. And from the new terminal, I want to test that I can retrieve all users and using the curl. So I'm going to send also a curl request for the API to get the information of user 4. So the username is Jake. And we moved completely to task 3, where we are going to study the containerized application in the Amazon Elastic Container Service. Now, the idea of Amazon Elastic Container Service, and I'm going to do a specific tutorial, a simple one, for Elastic Container Service. You specify a container, and that container will be in the registry of an image registry in the repository, and you can pass a task definition, and that task definition will be executed in a cluster. So the first thing you need to do here is basically to provide and to create a repository for your code. So you are going to go to Elastic Container Registry. And from the Elastic Container Registry, we are going to create a new one, and we will call it mb-repo and create. Now, this is the first repo we are going to use. Now, we want to build and the application Docker image, and we want also to push it here to the registry. So we are going to go to this folder in the container here. And from that folder, we want to push it back to our registry. So you can close the previous terminal and just work here in the 2- container. So in this 2- container, we have a Docker file, which basically using the alpha Node.js as a starting seed for the container image. We create a working directory called SRV. We install LPM in it, and then we expose port 3000, and then we run node server.js, which is basically the server.js that has and contain the application API code. Now, in step 28, they are asking you to install AWS CLI tool. Now, normally Cloud9 comes with AWS CLI, but just to make sure we have the CLI running and installed, because we are going to communicate now from Cloud9, we're going to push the image here to this repo. Now, let me export the environment variable, and now we want to authenticate our Docker client to use the Amazon registry, the Amazon Elastic Container Registry Service, and we want to push that command. Now, the steps are here in the lab sheet in step 32. They are the same steps when you go to the repository and you select it and then you view the push command. So these are the same steps you are going to use. So this is going to use a retrieve an authentication token to authenticate your Docker client, which is this Cloud9. So let me clear this. So I'm going to paste it as it is. Now, in your case, you will have different commands than my commands, but with the same tags. Then I will tag the Docker image with mb-repo, and then we will build it, and then we will tag it with the exact URL for the Amazon registry. And then finally, I'm going to build that image with the new tag, which is the URL for my Amazon Elastic Container registry path /mb-repo, which is the repository I have. And now I will use the command in number 4 here to push that image to my registry there, and I tag it as the latest Docker image. Now, once this command executed successfully, you should be able to see in your image mb-repo, you should be able to see the new image of the Docker container here. So the first thing we need to do is to copy the image URL, and we will save it here as mb-repo, because later on we are going to use this into loading our Docker container into a task, and we will ask the container registry, the container service, to run it in a cluster. Now, this is equivalent to go to Docker Hub and pull an image. So instead of pulling the image from the name /mb like this, you are going to pull it not from Docker Hub, but from the Amazon Elastic Container service in the Amazon Elastic Container Registry service. So this is the point of this step here. Now, once we finished and built the images, what we need to do in the following task, which is task number 4, is to deploy it. Now, the first step to deploy an image to the container registry to the Elastic Container cluster is basically we need to create a cluster. Then we create a task definition, and we will tell that task that we are going to use this image here, and then we will create a load balancer, and we will deploy the application in the Amazon Elastic Container services cluster, and then we test it. So now let us go to task number 4.1, where we need to create an Amazon Elastic Container service cluster. And this is going to be from here. We go to Amazon Elastic Container Service. If you are interested to learn more, you can use the Get Started, and this is give you a sample application so you can test it around. But in our lab, we are going just to create a cluster. Now, the cluster could be run in multiple ways. It could be in a network layer only. You want to create a cluster with a network layer, or with Windows machines, or with Linux and a network layer, which basically it will launch an Elastic Container EC2 instances and a VPC. So click next step. Now, if you look back to the guides in the lab, you want to call this MB Elastic Container Service Cluster with on-demand instance. The on-demand instance will be a T2 micro. So you're going to look to T2 micro. And the number of instances we want in the cluster, we want 2 EC2 instances to be executed at all time. And now we need to create a VPC. Now this VPC will have the IP 10.32.0.0/16. The first subnet is going to be 10.32.0.0/24, and the second subnet is going to be 10.32.0.1.32, and we will create a security group with the default from any IP to open port 80. And the role here is going to be the container instance IAM role, which will be created to give permission for the cluster to create a new EC2 instances and invoke them here. So we will use the Elastic Container Service instance role in this, which authorizes the EC2 instance in the cluster to invoke a new Amazon Elastic Container Service action. Click now in create, and that will create the IAM policy, the EC2, the Elastic Container Service instance role, and then we'll create a CloudFormation stack. And now we'll create a 2 EC2 instances, and you could go back to your EC2 in a new tab, for example, to check that these are under creation. So this is the Cloud 9, and we need to wait for the cluster to finish and to deploy all the resources. So view cluster, and now in the cluster, you need to come to the Elastic Container Service. And to see that there is an Elastic Container Service instances here, you keep refresh this until you can see 2. So I will pause the video and I will keep waiting to see that I receive 2 Elastic Container Service instances. So this is the first Elastic Container Service, the first EC2 cluster, and this is the second one, and they both initializing. So I need to wait here to see them in this tab, which basically I can see both of them. Now let us go back to task number 4.2. In task 4.2, we want to go to the task definition, and we create a new task, and this task will be launched in an Elastic Container Service EC2 instance. So we are going to select that and click in the next step. Now the task name should be Monolithic Application Task, and this will come with a container. So we have a container here, and we can add a container definition. By the way, here in the container image, you can pass any Docker container in the same way you pull it from Docker Hub. And I will call this MB-container. Now, what I need to paste here, what I need to paste is the URL for the image for the MB repo, the one I just used to push. So this will come here, okay? And the hard limit, it will be 256, which basically we are telling the minimum memory limit, the maximum memory limit is going to be 256 megabyte. And the port mapping, you could map a specific port here, like you could map port 80 to 3000, but in the lab sheet, we just want to map the 3000, the container port, which we basically expose it using this Docker container file. The Docker file is exposing this port, and now we click add, and then we go all the way down and we create. So this is our first task definition, and you can create multiple revision of the same task definition because you could tune it and configure it with different settings. Now we want to create an application load balancer. So we need to go to the Elastic Container Service from services, we go to EC2 just to show you, because this maybe sound a bit odd. And we need to create it in the same way we used to create in the past an autoscaler and launch a load balancer. And we come to the load balancer and we create a load balancer. This is going to be an application load balancer. In step 76, it's asking us to call this MB load balancer. It is a public-facing one, and it should be operating in the VPC 10.32, in the first availability zone, and in the second availability zone as well. And this is basically internet-facing, and then we need to use here, we are going to use the VPC 10.32, US East 1 and US East 1B. Now for security group, we want to select an existing security group. So you want to delete the default or deselect it and select this security group, which was created by the cluster here. Once we launch the cluster, it was created once we launch and create this cluster. So go back now, keep this security group there. And now for target group, we want to create a new target group, which means we are going to open a new tab. Now the name of the target group is going to be MB load balancer target group. Make sure to use the same naming convention in this lab, because there is multiple target group you are going to select. In the advanced health check, we are going to put the health threshold to 2, which is the number of health check that will happen before we declare the target healthy or unhealthy, and the interval, how much time between health check. Instead of 30 seconds, we want to put this and we keep it to 6 seconds, just to get more fast result from this target group. Then click on create a target group. Going back to the load balancer, just refresh the page, and now you will be able to see that there is an MB-load balancer target group selected, and the rest will be to create a load balancer with the default, and just now view the load balancer. Now in this particular step here, in step number 89 and step number 80, we want to go to the security section of the load balancer, and we copy the security group that we use for this load balancer, and we save it in our notepad or in our text editor. So let me call this the ELB security group, and just paste the ID that I'm going to use in the future, in a future step. Security groups, and this is the Elastic Container Service security group that we have. We go to the inbound, we edit, and now we need to enable a custom TCP port, which are these ports here, 31,000 to 61,000. And the source is going to be the Elastic Container Service security group, which is basically here we are just allowing the cluster to communicate with the load balancer, or to send the traffic via the load balancer to each other. And basically these will be used by the Elastic Container Service cluster to do orchestration, load balancing, and so on. Now click save, and let us move now to task 4.4, deploying a monolithic application. We need to go back now to the Elastic Container Service, and from the Elastic Container Service, we need to go to the task definition, and we select the MP task that we just created in the previous task. And now we will select that task and we create a service. Select it, then actions, create a service. Now this service configuration is going to be run on an EC2, not in a Fargate, and it will be run in MB-Elastic Container Service cluster, and we give it the service name MB-service -service. And the next thing, we need to keep it replica, which means it will be replicated meaning that each container service EC2 instance or EC2 container service will be running a minimum one container to support this task. The number of tasks is going to be 1, and it will be an AZ balanced, and then click on create or next step. It will be run behind a load balancer, and that load balancer is going to be the load balancer we just created in the previous step, the MB-load balancer. And we want to add the container port, which is port 3000, to the load balancer. And we will use the current one, which is 80 HTTP, as a target. And the target group is going to be the MB-load balance target group. And then click on next step. There is no need to set up auto scaling. If you create an auto scaler, this is going to create more EC2 instance to support the Elastic Container Service cluster. And then create a service. Now, this should take a few minutes to create the service, and that service will be executed in the Elastic Container Service cluster on the cluster we just created. So you could go to Elastic Container Service and into your cluster, and you will be able to see there is a new service created. Now you need to wait for the number of running tasks to be 1 here, and you want to see also a specific task running in the container service in an Elastic Container Service instance. Now let me go back and wait for this to view the service, and you can see the service is basically running. And after you wait for a few minutes, maybe you want to test this application in task 4.5. And the testing is going to be very similar to what we did in the past. We go to EC2, and from EC2, we need to go to the load balancer, and we copy the DNS name of the load balancer, and we open it in a new tab. Maybe I just use this tab here. And we will wait for this tab to display basically the application that it is now ready to receive the request, which means our API is ready for us to send them a GET request to get a specific resources from its root, like API/users, API/threads, and so on. So this is now task 4.1. In task 4.1, you could also, from the load balancer, just do /API, and this should give you back the API ready, API/users. Now this should give you the list of the users that you have, and so on, similar to the curl application testing that we did. Now in task 5, we want to refactor this application, and we use microservices and the thread services and post services in a separate Docker container. So let us do just that. So after you review the 3 containerized application from the Cloud9, you will find that in this we have 3 different folders, one for the post service, one for the thread service, and one for user service. And each one of those, it contains a Docker file, which means we will run them each one as a standalone Docker container as a microservice. So here we are just running node server.js, which basically putting the logic for the post service in the service.js. So we don't mix the logic of user services with the thread services and with the post services. In the same way, in the threads, we only implement the threads. Here, the thread ID, and to get all the threads. And in the user services, we are getting also the user API call. So only /API/users/API/user/user ID to get a specific user. So in the process here, we are going to create an Elastic Container repository. Let me explain the generic model of that. And once we finish that repository, we use the command available from the Elastic Container Service repository to push each one of these Docker container as an image in the repository here, and then we create a task for each repository, and we execute these tasks as a service in the cluster. So let us start doing this right now. So from here in the Elastic Container Service, we want to go to the container registry, and from the container registry, we create a repository. And the first repository is going to be the mb-user repo. Create. Now, in that user-repo, there is 4 steps we need to do. So we need to go back to the Cloud9. And now you could go and make sure in which path you are working on. So it's very important to be careful here in this step. So let me go back /environment, and this is going to take me to 3 container service. And inside it, I want to go to the users. And from the users now, I want to push the image. So let us go now to users in step 135, and we do these steps. First, we authenticate. Second, we build the Docker container as we build the image, sorry. And then we tag that image. And you can check, for example, by putting Docker images, and you see the images that you just built. And now we tag the image for the users. And finally, after we tag it in step number 4, we want to push it to the container registry. And now we are just pushing the image, which means if you close this tab here and you refresh, you will be able to see the image URI. Let me save this under mb-users-repo, so I could refer back to it later on. And let us move on. Now go back to the repository, and now let us create the next one, which is going to be for the thread. So we are going to create a new repository for the thread. So we are going to go back to our repository, and we select and we create a new thread called mb-threads. Create, and now from the threads, we want to get the push commands, and in the same way, we go back to Cloud9, and we do cd ... to go back, and then cd threads. And now, let me clear this. Paste the first command, which is to authenticate. Then the second command, which is to build. Now the authentication step 1 is not really necessarily, because I already authenticated this, but just for the sake of the demo, I just want to keep doing the steps so you know these steps. Sometimes also the Cloud9 give you a timeout session, so you could go back and authenticate it again, and you know which step is doing what. Let us now tag that image. And we need to push that image container back to the container registry. Now the next step is going to go back, copy the image after you refresh, copy the image URI, and this image is going to be saved as mb-threads-repo. And this is the image repo that I just saved here. And you see, this is basically my account / the name of the image / the tag, which is latest, the one I used to tag this image. Let us go back, create a repository again. And now this is going to be the mb-posts. And that mb-post is going to be used to push the image for posts. Go to that post repo, view the push command, and in the same way, go back to post. Let me clear so this will be obvious. And now build the Docker container image, and then tag it with latest. and then go back and push that latest image into the container registry. So at this point, we managed to push the posts, the threads, the users, all the way back to the repository. So by this step, you should see 4 different repositories there in the Elastic Container registry. Now, the next step after we pushing these images is to deploy them. And deploying them, this means we are going to ask the user to send a request to the Elastic Load Balancer, and the load balancer has different listener. Each listener, like /API/users, is going to forward that request to the container running the user logic. Also, /API/threads is going to be sent to the microservice running the container of the posts. /threads is going to be running the threads, and /post is going to be running to the /post container. So to do so, we need to go now to the task definition, and we have to create a new task definition for each service. So we are going to create a new task. This is Elastic EC2 instance, and the first task here is going to be in step 195. Is going to be the MB user task, and this is going to be by adding a container, and that container will be the MB user container. And the image URI for the MB/user is this one here. I think I forget to take the container registry for the last one, which is the post. So let me go back now to the container registry and the post one, select the image URI and just save it, just in case, to keep everything easy to follow. And this is posts-repo. And this is the -repo post. Now let me go back, sorry for that, just to keep this in the right way. And the hard limit is 256. And now we need to expose port 3000 in this container. And we don't have any other configuration for this container, so we add it and we create a definition. Go back to the task definition and create a new one, and this new one is going to be the thread task. So we are going to create an MB threads task in the same way with the same settings. Pretty much nothing will be changed here. Add a container, and the container will be MB-threads container. Now go and get the threads URI and paste it here. Don't forget the task hard limit 256 and the container port, which is the 3000. Click add and then create a task definition. Go back to tasks. You can see now we have a threads task, we have users task, and we need to create one more, which is basically going to be the last one for the posts task. Click post tasks and now add a container, and this is going to be container and now let me copy the post container URL for that image. The hard limit 256, port container port is a 3000, and click add and then click on create. Again, we have now the original MB task, and now we have 3 different tasks for each one of those microservices. And now in task 6.2, we want to configure the application load balancer, because we have to be careful on the way how we configure the load balancer, because now we will select multiple listeners. So let me go back to the EC2s, and now in the load balancer, I want to go to select the load balancer, and you can see there is a listener here. Those listeners, we are going to edit and view them. And the first thing we need to do, guys, is basically to create multiple target group in order to respond to these listeners. So before I create and modify the rule, let me go back and create different target group. And the first target group is going to be the load balancer for the users. Okay, and this basically the one that will take the request for all API/users request. And this is going to be in that VPC. In the same setting for the advanced health, it's going to be the health threshold is going to be 2, and the interval is going to be 6. And click next. This is the health is 2, and here we want it to be 6. Click next, and now create a target, a group. Then create another target group, and this one, it will be the threads. So this is a target group, will handle all the API requests to the threads, /API/threads/API/threads/the thread ID. And now select the same VPC, and the same settings for the health check is going to be 2 here. The health threshold and the interval is going to be 6 seconds, and then click next, and then create a target group. And the last one is going to be the target group for the post. So we're going to create a target group. We call this here NB-ELB post in our VPC where our cluster is running, and with the advanced health check is going to be the same setting, 2, and the interval is going to be 6 seconds. Click next. You could restore the default sometimes if you change like one of these values which you are not supposed to change. Click next, and then click on create. Now, as you can see, we have the old target group, the one we used in the application, which was one monolithic application running in a Docker container, and now for post, threads, and user. At this stage, you could go now and start to work in step 221, which is the one I said to you. You need to be careful when you work in this step. There is many configuration you need to pay attention to. We go to the load balancer, to the listener. So normally you can see the listener from here, then you view edit rules. And now what you need to do is to add a new rule, and you can insert rule in the above. And the rule here is going to look for any request going with the /API path /API/users star, which means we can also, it will also capture any request like this /one user. So this is also will work. And now this is going to be the action. We will forward this to our users group. So that's the first configuration. That's the first rule. The second one is going to be after you click save, insert another rule. So we need to start users, then target. Let's go path. And this will be the threads. And the action will be to forward this to the threads target group. And click save. And now add another rule. And that will be the /API/posts star. Now this will forward the traffic to the target group posts, and click save. Now we have rule 1, 2, and 3. Now in the last one, which is the rule for the last, rule 3, we need to add another one. And this is pretty much will be going to get any request with the value / or /API, which is the default API, which is not going to call a specific route from the implementation in server.js. Now this will take us and forward to our target group, which will be the MB-LB users target group. Click Save. And now you have multiple configuration as well. So the first one is the first rule going to the users, the second one going to the threads, and you can just verify what you have done from the steps we did from step 2.1.1. You can double check the threads and the users target group, then the posts. And finally, now we want to basically edit the rule, which is the default one, the last. We want to edit it using this icon here. And we want to edit it by saying, and we add an action to return a fixed response with the response code 200. And in the body, we just say an invalid request. And click Save and click Update. So basically we have now done all of these steps. So once we finish the update, we could go now to the back of our load balancer, and you can see now our load balancer has different responses as well. How we can make this load balancer work with our task definition in the Elastic Container Service, we need to configure them. So we need to go back now in task 6.3, and we need to go to the Elastic Container Service, and we choose the MB cluster that we create. And in the cluster, we want to select the services, and we create a service. This is going to be the Elastic Container Service. And in the first service, we are going to select the user's task, and we will call this an MB users dash Elastic Container or ECS service. With the same thing, it will be a replica with one task definition, rolling update, click next, and this will be our load balancer. And we'll use the MB dash load balancer, and we will add the load balancer. And now this is going to be the target group for the user. Okay, and then click next, and now it create a service. Now the next thing is going to basically repeat the same thing for the threads service. After you finish the creation of the first service, you can go back to your Elastic, maybe from a new tab, go back to the cluster and select the cluster again, then create a service, and this will be EC2, and this will be the threads, and that service will be called MB thread ECS service, one replication, one task, and now click next. Attached to a load balancer, it will be the MB threads as well, and this will be the target group for threads, and click next and next step, and then create a service. So this is pretty much the second one. You could also go and open it in a new tab once this is finished. So you can see there is 3 services now. Create the last one, and this will be our a post service. So the post task is going to be called MB-post-ECS services. In the same way, we go create next step, and this is going to be EC2, the name of the service. For some reason, I don't paste that correctly. Number of tasks is 1, and then create or click next, load balancer, and from the load balancer we will container, and we will use the same, but this time is going to be the post target group, next, and then create a service. So we will wait now for these services to complete. Now, if you go back to your container service into your cluster, you will see that these services are now start to run. So we can see each, for example, the user service is running on this target group, and everything seems to be fine. So go back to your cluster and wait until you can see all of them are running. So you could also check the task that you have, for example, for the post, the user task, for example, you can see here, you can also retrieve the container itself, and you can see the container expose port, and that's the reason why we open a new port for port 31,000 to 61,000, because these are going to be used by the Elastic Container Service cluster. So at this step here, after you see the 3 tasks, we want now to validate our service. So you could go now to your deployment in the service itself. So you can select, for example, the service of the user, and you can update that service, by the way. And these updates can take different deployment as well. So let me now look in task 6.4. So we have now to update a service, which is the original service we create. This service here, we are going to update it, and we will say now this service, we are not going to run it, so run only one task of it. And that's pretty much what you need to do. So this service, it will have 0 deployment or 0 running count. And you can check that from the service view. So when you view the service, you can see that this is now the desired count is 0 and the running, and it will start now to stop all the MB Elastic Container Service containers, or stop these containers from the cluster. So we will open now a new browser tab, and we will use the load balancer. And from the load balancer, we are going to enter /API to test our application. API is ready. This is what I'm doing for step 231. Let us retrieve the first information of the first user. So this will be users /1, which means we are asking the user to get the first communication from the container. Let's retrieve user number 4. And now I need to retrieve the threads. So this is, I have API here, /user4. So this should give me the user 4 details, user 1. And the last thing I want to test is the threads. So the threads should, and you see what it will, the API tell me it's going to give me a bad request every time I miss the specific URL for the request. So this is pretty much what you need to do for this lab. Thank you for seeing this video.